Trying target 38 says I can graph a sinusoid given its equation. So for these questions, we'll be giving you the equation and you're going to need to come up with the graph for it. So similarly to when we give you a graph and have you come up with an equation, the first step is going to be to identify all the important features of that function, and then we're going to try to put that together to come up with the graph. So let's look at our equation. We know that the general form for a sinusoid equation with cosine is y equals a times cosine of 360 divided by the period times x plus the midline. So from the equation we can identify some of the important values. So amplitude is the number that's right in front. So in this case our amplitude is 2. The midline is the number added on at the end, so in this case, -5. Now, the max and the min don't just appear in the equation, but you can kind of come up with what the max and the min should be. So remember, to get the max, you start at the midline value and go up by whatever the amplitude is. So in this case, if we start at -5 and we go up by 2 units, our max will be a -3. If we start at the midline and we go down by 2 units to get the min, our min will be down at -7. So our max is going to be a -3 and our min is going to be a -7. So now let's think about what the period is. So it's a really common mistake to want to say that the period is 10, but the period is not 10. You know that 360 divided by the period equals 10, but you don't know that the period is 10. So we do have to do a tiny bit of algebra to come up with what the period is. So the idea is that 360 divided by the period gives you 10. So we can just sort of set up an equation, 360 divided by the period equals 10, and then solve for the period. So right now P is in the bottom of our fraction. So to get that out of the bottom of our fraction, we're going to multiply both sides by P. So we end up getting 360 equals 10 times P. But our goal is to get P by itself. So we're going to divide both sides by 10. And we get that our period is 360 divided by 10, which is 36. So our period is going to be 36. So the next thing that we have to decide is, based on whether this is a sine or cosine equation, and based on whether it's positive sine or negative sine, positive cosine or negative cosine, that's going to tell us what happens right on the y-axis. Where does our graph start right on the y-axis? So in this case we have a positive cosine. So remember, if it's a cosine, we're either going to start at a max or at a min. So not the midline, not these ones for the cosine. And then we have to decide, well, is it a max or is it a min that it's starting at? So if we have a positive cosine, it's going to start at the maximum. So we're going to start at a max, not at a min. Okay, so now let's try to develop our graph. So I'm going to draw in my y-axis. And now I'm going to think about where should I put my x-axis. So if I think about the y values that have to come out of this, my y's have to be between -3 and -7. So I might put my x-axis sort of like up higher to make more room for negative values. So I don't know, maybe put it up here. Okay, and we'll talk about the scale on the x-axis in just a minute. But let's just put on the first point we know, which is we know that we start at a max. So let's think about where the max is and where the min is. So the max is at -3. So I like to draw sort of a dotted line for the max. and a dotted line for the min. The min is at -7, so that's down here. And that sort of reminds me, don't go above or below these two lines, because those are our max and min. And then the midline is here at, darn. So the midline is here at -5. Okay. Now we know that we started a max, so we can put that point on our graph. We started a max on the y-axis, so we know we have this point here. I'll put it in blue. Okay. Now, the period is 36 units. So that means that it's going to take 36 units to complete a full cycle of the graph. So we better change the scale in the x direction so that one box isn't like 1 unit, because we're definitely not going to be able to complete a full cycle of the graph with just on this graph, right? Because we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we only have 24 boxes this way to work with, so we can't make each box be 1 unit. So instead, maybe we could make each box be 2 units, for example. So if we make each box be 2 units, it'll only take us like 18 boxes this way to get to 36 and complete like a full cycle of the graph. So let's start labeling our x-axis a little bit. So if we make each box this way be 2 units, it's going to take us 18 boxes to get to 36. We want to make sure we fit a full cycle on our grid. So let's count this way by 18 units, and that'll tell us where 36 is. So let's see, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. Okay, so right here, that's where 36 units is going to be, and that's how long it's going to take us to complete a full cycle of the graph. So let's label that. So over here, that's 36 units. So then right in the middle will be 18 units. So let's count 1, 2, 3, 4, 6, 7, 8, 9. So this is where 18 units will be. Then halfway between here will be 9 units. So let's count that. So that's going to be over here at 4.5 boxes. That'll be 9. And then over here, that'll be 27. So now we've sort of established what the scale is on the x-axis, and now we can continue drawing our graph. So if the period is 36, that means that this graph is going to complete one complete cycle and end up back where it started after 36 units. So if we start on a max point, after 36 units, we're going to complete a full cycle of the graph and end up back in the same exact place at a max. So at 36, we know that there's going to be a max there. Now let's just remind ourselves quickly what the cosine graph looks like, sort of just the normal cosine graph. So it starts at a max, goes down to a midline point, then it goes to a min, then a midline point, and then back up to a max. So this is what the cosine graph looks like. You have a much better picture on your reference sheet, but this is what it looks like in general. Starts at a max, goes down to a midline, then a valley, or min, then a midline, then a peak. So if you notice, the peak happens right in the middle of the two maxes. So we can figure out where that is on our graph. So right smack dab in the middle of these 2 points is here at 18. That's where we're going to have a minimum point. And then halfway between, notice that halfway between this point and this point, that's where we hit a midline. So halfway between this point and this point, we're going to hit the midline. So that'll be right over here. Same thing here, halfway between this min and this max, we hit a midline point. So halfway between the 18 and the 36, we're going to hit the midline again. So that'll be over here. And then if we have more space on our graph, we can continue and do like another cycle, and it would just sort of continue the exact same process. So it took 9 units, which was really 4.5 boxes, to go from this max to this midline. So the same thing is going to happen with this max. It'll take 9 units this way, or 4.5 boxes to head down to the next midline point. So that'll be like down here, and then it'll keep going from there. So then we can just sort of draw in the rest of our graph. This is really hard to do on an iPad, so I'm sorry if it turns out terrible. Okay. So you get the general idea. Pretend that the graph doesn't actually go below the minimum line. So there is our graph. So let's do one more example. Okay, so this equation is -3 sine of 18x plus 2. So again, we're going to go through the equation. We're going to identify all the important features. The midline is going to be the number that's out here added on the end. So our midline is a positive 2 this time. The amplitude is the number out in front here, but we're not going to write down the -3. We're just going to write it down as positive 3. Because the negative doesn't really help us to determine the amplitude. The negative helps us to determine down here at the end, like where do we start on the graph. Another way of thinking about why we make the amplitude always be positive is on the graph, amplitude counts the distance from the midline up to a peak, or from the midline down to a valley. So we're counting boxes. It's like the number of units. It's a distance between one thing and another, and so it doesn't really make sense to have a negative amplitude. So make sure that you always list the amplitude as a positive number. Otherwise, it can get you a little mixed up. So to find the max, we're going to start the midline, and we're going to go up by the amplitude. So if we start at 2 and we go up by 3, that means the max is 5. If we start at the midline and we go down by 3, we would be down at -1, so that means the min is -1. Now, the number in front of the x, that does not tell us the period, but it does tell us that 360 divided by the period equals that number. And then we can just solve for the period. So we multiply both sides by p. We get 360 equals 18p. And then we divide both sides by 18. So we end up getting that the period equals 20. So that is our period. So the next thing we have to do is we need to figure out, based on whether this is sine or cosine, based on whether it's positive sine or negative sine, we need to think about what's happening on the y-axis. Are we starting at a midline point? Are we starting at a max? Are we starting at a min? Where are we starting? So because this is a sine, we know that we're going to start on some kind of a midline point. So we're not going to be at a max or a min. That's for cosine graphs. So it'll be some kind of a midline point. And the way that we decide whether we're starting at the midline going up or the midline going down is we look at whether there's a negative in front or not. So if there's a negative in the front, that means we're going to start at the midline heading down. If there's not a negative, that means we're going to start at a midline heading up. So in this case, we're going to be starting at the midline heading down. Okay, so let's try to start drawing our axes. Pretend that's a straight line. So there's our y-axis, and so now let's think about where our x-axis should be. So our y values fluctuate between 5 and -1, so maybe put it sort of somewhere in the middle, but a little bit more room on the positive side, so maybe like over here or so, just so that you have enough room to go up 5 and down 1. So maybe here-ish. Okay. Now our period is 20, so let's sort of pause and think about the scale on the x-axis. On the y-axis, we can just do 1 box equals 1 unit, because that'll fit. The period is 20. Now, on this grid, I think we do actually have enough boxes going this way for it to fit if you want to make each box be 1 unit. So that would be fine if you want to do that. Alternatively, you could change the scale and make each box be 2 units, for example. So I'm going to do it that way just because I think that people in general have a harder time with that. But you could make each box just be 1 unit. Okay, so if the period is 20 and we make each box in this direction be 2 units, that means that after 10 boxes, that'll be a full period and we'll complete a full cycle of the graph. So let's see. So over here would be 20. So that means halfway between that would be 10. Halfway between there would be 5. Halfway between there would be 15. So those are some values to get us started. And then we can sort of keep going. So if we went another 10 units, we'd be up at 40. Halfway between would be 30. Halfway between here would be 25. Halfway between here would be 35, and so on. Okay. So now let's start to put in where do the max and the min happen. So the max is at positive 5, so I'm going to put in a little dotted line up at 5. And that's our maximum line. Our minimum line is at -1, so I'm going to put, it's terrible, another little dotted line down there. Sorry, it's really annoying doing this on an iPad. Okay, so there's our minimum line. And then our midline happens at 2 up here. So I'll put another dotted line there. Okay. Now, we know that we start at the midline heading down. So therefore, on the y-axis, we'll have a point on the midline. And it'll be heading down. So that way. Okay. Now, since the period is 20, that means that after 20 units, we're going to have gone through a full cycle of the graph, and we're going to end up in the exact same place that we started. So after 20 units, we should end up back on the midline. Now, let's just remind ourselves what a sine graph looks like. So I'm going to sketch a picture over here of what a negative sine graph would look like. So a negative sine graph will start at a midline. It'll head down to a minimum, back to a midline, up to a maximum, back down to the midline. So this is what like one cycle of a sine graph looks like. Start at the midline, negative sine graph. You start at the midline, head down to the minimum, back up to the midline, back to the maximum, and then back to the midline. So we want our graph to follow the same sort of pattern. So if you notice, halfway between this midline point and this midline point is another midline. So let's put that in. Halfway between these 2 points, a minimum happens. So halfway between here and here, we should be at a minimum. And then halfway between here and here, we should be up at a maximum. So you can fill that in. So this is one full cycle of the graph. And then if there's more room left on our graph, we should do another cycle. So we'll go down to a minimum, back up to the midline, up to a maximum, back to the midline, down to a minimum, and then if there was more room, we would go up to another midline. And then we can just connect the dots and make a nice wavy shape. Okay. So let's think about our general steps here. So the first thing we did was we identified all the important characteristics. We sort of labeled the x-axis and the y-axis. We sort of drew in a little dotted line for the max, the min, the midline. We thought about our scale for our x-axis based on the period. Then we figured out sort of where are we supposed to start. And then we used what we know about the general shape of a single cycle of a sine curve and a single cycle of a cosine curve, sort of follow that pattern and put the rest of the graph together.